Hello, Calc Wizards, and welcome back to another problem. Tonight we are solving this highway design problem, problem number 62 and 3.1 here. It's an exciting problem. It's pretty long, so we're going to try to go pretty quickly here. And if you need to pause, feel free to do that because I'm going to go rather fast. So in this problem, they gave us a nice diagram, and they're saying that we are building a highway above this valley, this very theoretical valley where we have a perfectly 9% grade hill leading into another perfectly 6% grade hill. And before we get into the actual solving of this problem, we need to understand what 6% and 9% grade mean, which are actually pretty simple. Lots of tabs. Okay. Um, so let's talk about that. It comes from the tangent function. And this is my first time using this writer, so seems pretty good. If we have an angle theta, tangent of theta is equal to our height over our base here. Now, if I told you that the tangent of this theta was 6%, that would mean that we have 6 over 100. This is actually a 6% grade, but that means that if I find the eraser here, that would be good. Um, I don't think that's it. Okay. Well, yeah, so that would mean that we have 6 over 100, which is not drawn to scale here. Um, but that's what a 6% grade means. So let's go back to our problem. This is a 6% grade. This is a 9% grade. That'll come in handy. So, what else do we need to go over? I think we can get right into it. They gave us a nice XY coordinate plane, and they're telling us find the coordinates of A and B. So, let's go back to this diagram. We know that for B, we're talking about a 6% grade, but instead of it being a base of 100. Now we have a base of 500, and that just comes from the 500 feet that they have here. So the base is 500, which means that our height is just a similar triangle, 6 times 5, because we multiplied the 100 times 5, which is just 30. So our coordinate for B is 500, comma, 30. Now, the same thing is true for A, right? Now we have a negative 500 here, and this was a 9% grade, but we need to multiply that by 5, so we get 45. And our point here is negative 545. So that's our answer for part A. We have our 2 points. Now we get into the calculus. So, or maybe not quite yet. Now they're asking us to find a quadratic function that fits this curve here. I'm trying to annotate. Let me see if I can do that. Okay. They want us to find a quadratic function, which you can imagine looks like this, except instead of it being that curvy, we want one that's a little shallower and fits this curve that they have here that I'm trying to draw. So it looks something like that, right? Um, so we need it to be in this form. We have 3 unknowns though. We have A, B, and C. So one thought is we have these 2 points for A and B. Why don't I plug in 45 for X and negative 500 for Y, and I'll get one equation with A, B, and C, and then I'll plug in, oh, I had that point backwards. It should be negative 545. That was A, and 530 for B. So why don't I plug in 530 for X and Y, and I'll get another equation for X, B, or for A, B, and C. Well, the problem with that is then I have 2 equations and 3 unknowns, and I won't be able to solve for A, B, and C. So we need to find another way. We need to find another way to find A, B, and C. Let me see if I can erase all of this. Erase. Okay. Just delete everything. Okay. Yep. You can just go back if you needed those. So we have this form for a quadratic. And we need to solve for A, B, and C. We know we have these 2 points. There's actually something else that we also know, and that's going to be key to solving this. And we know that the instantaneous rate of change at point A is the slope of the hill, which is -9/100. And we know that the instantaneous rate of B is the slope of this hill, which is rise 6, run 100, 6/100. Same way that we found the percent grade. So, well, why does instantaneous rate of change matter? Well, this is calculus, so instantaneous rate of change is the same as dy dx, our derivative. And instead of writing dy dx over and over, I'm just going to write y prime, which is going to be equal to 2ax plus b. And if I'm talking about y prime at a, then I'm talking about the derivative evaluated at a. It's kind of my own shorthand. It's not really how you would normally write it. Well, that would be 2a and then our x value at a plus b. And we know that the slope at that point is a 9% grade and it's a negative slope. So we have a slope of -9/100. Similarly, y prime at b, at point B, our instantaneous rate of change, we can substitute our value of x at point B, which is 500, and we can substitute our instantaneous rate of change for dy dx, which is 6/100. Now we have a system of equations with 2 unknowns and 2 equations. So we have a and b, and we can actually use elimination here. If I add these together, I get 2b equals -3/100. So b is equal to -3/200. And we're off to a messy start in solving this, and I'll save you a little time because I solved this earlier. I trust you can solve this system of equations to get A, and we would get 15/200,000. So we're almost there. We just need C. And to find C, you can do exactly what we're going to do before, which is plug in either A or B, and we can use A, which is -500, comma 45, and solve for C, and you would get that C is equal to 18.75. So we have A, B, and C. So we can write our, just going to make a little bit of space here, kind of arbitrary what I'm erasing. We can write our quadratic as this. Beautiful. Not really. Kind of really ugly numbers, actually. But I think you're allowed to use a calculator on this problem. I would hope. Maybe. No. Actually, I think the numbers, you'd be able to do it by hand. It wouldn't be too bad. Anyway, that's what they wanted for part B. So let's take a look at part C. They want us to construct a table giving the depths D of the fill. So they're talking about asphalt that they're filling. Which I don't know if they would actually do it that way. That seems like a lot of asphalt to put here. But anyway, in the calc world, that's how we're doing it. They want the depths D of the fill for these different X values. Well, our first X value is here at -500, and that depth is obviously going to be 0 because there's no asphalt to put there. But let's talk about this depth. I'll call it D1. Well, that depth is going to be the distance between our hill. I'll call that the hill height, H, capital H. Well, it's going to be the difference between the hill height. Actually, sorry, it's not the hill height that I labeled there. That would be the road height, the height of the road. And I'll call that R, capital R. The distance between our road height and our hill height would be our depth. So we're going to call D our depth, road height minus hill height. And we're going to do that for negative 500, negative 400, 300, 200, 100, 0, 100, all the way back to 500 here. And the way that you can do that, well, what is our road height and what is our hill height? Well, the road height is just the height at any given x value of our road, which is our quadratic that we have here. So for every x value, we would just plug it into here. Okay. Plug it into here, and we'd get a y value. That's our road height. Our hill height, well, this is just a really simple linear function where our slope is negative 9 over 100, and our y-intercept is 0. So that function is just y equals negative 9 over 100x. And our hill height here is also a really simple linear function, y equals 6 over 100x. So we have a way of getting our road height and our hill height. And now it's just a matter of plugging that in. Well, if you didn't want to plug it in a bunch of times, you could use your graphing calculator and set y1 equal to our parabola and y2 equal to this linear equation, and then y3 equal to this linear equation. And then you could set y4 equal to y1 minus y2, and y5 equal to y1 minus y3. So this is your depth here, and this is your depth here. Well, I don't have a way of doing that on my computer with the graphing calculator, but what I did is I just created some functions in Excel, and our road height is our quadratic function. Our hill height is that linear function, and it changes once we get to the positive values of x. I change it to the 6 over 10 slope. So here are all our road heights. Here are the hill heights. And then our fill depth is just going to be our road height minus the hill height. And I added a little color scale so we can see where it gets deeper. And it gets deeper right in the middle, which is kind of what we would expect based on this diagram. Okay, so here are the depths that we have. And something interesting to note is that these depths are symmetric with respect to our vertex. Kind of cool. Okay, and in part D, they ask us what will be the lowest point on the completed highway? Well, the lowest point, they're talking about the vertex of our parabola, which would just be negative b over 2a. And if you solve for negative b over 2a, which we can do, negative b over 2a is equal to negative 3 over 200 over 15. Oh, this was 2 times 15 over 200,000. Let me make sure I have those numbers right. Yep, looks good. So this is equal to the negatives cancel on the top, and this is just another way of writing this. These cancel, we get a 10. Cancels with one of those zeros. These cancel with 2 of those zeros. That becomes a 1. So 100 is our x value of the vertex, and they're asking us what will be the lowest point. Well, the lowest point occurs at 100. 100 feet. So I guess they want a y value for that too. So we would just plug in 100 into our quadratic that we had from earlier. And I'm not going to do that now because I think we can move on. Will it be directly over the point where the two hillsides come together? Well, the two hillsides come together at x equals 0, and we just found that the lowest point is at x equals 100. So no, it is not directly over that point, which we would expect because these points are not the same, A and B are not the same height, and we are using a parabola, which is symmetric about the vertex. So makes sense that it would be shifted to the right, the vertex would be. Okay, I think I got to each parts of these questions. Let me know if you have any questions in the comments. Yeah.